Hi, this is Mrs. Nearing here with some more balancing practice for you. So with these problems, we're going to keep going. We're going to start out by making my T-chart. I've got C's and H's and O's. C's and H's and O's. And remember our trick with this type of reaction, it's a combustion reaction where you've got a hydrocarbon and oxygen making water and CO2. One of the main tricks is to balance the elements in this order. So do the carbons first, then the hydrogens, and the oxygens. So remember CHO. So let's stop and count first. I've got 4 carbons, 8, and then I've got 1, 2, 3 oxygens. And over on this side, I've got 1 carbon, 2 hydrogens, and then 3 oxygens. So I want to balance out the carbons first. So I'm going to put a 4 here. That gives me 4 carbons. Another trick I have for you on this one is wait and count the oxygen. Wait to count the oxygens so you've already balanced the carbons and hydrogens. So I'm not going to count my oxygens yet. So now I've got 4 carbons over here, and then I put a 4 out here. That gives me 4 times 2, 8 hydrogens. Now I'm going to stop and count my oxygens. So I've got 4 oxygens from the water, and then I've got 4 times 2 from the CO2. So I've got 12 oxygens over here on the right. And then I go back here and I'm gonna look. Oh, geez, I've got this oxygen over here, this lonely oxygen. It's an odd number. Like I'm never gonna be able to get these two to add up to 12 because this is an odd number. So here's where I might say, let's try doubling this. Okay, so this is another trick. Sometimes in combustion reactions, doubling things can help. So let's make this a 2. Now I've got 4 oxygens on the left, and then I've got 8. So 2 times 4, 8, and then 2 times 8, 16 hydrogens. So I'm going to go back over here. I'm going to change this to an 8. Okay, that's going to give me 16 hydrogens. I'm going to change this to an 8. Whoosh, that's going to give me 8 carbons. And now let's stop and recount my oxygens. Now I've got 8 oxygens from the water, and I've got 16 from the CO2. So that's 24 oxygens. Okay, so 24 oxygens over here. I want to have 24 oxygens over here. So what you want to notice is I already have 2 oxygens from my C4H8O, and I want to have 24 total. So what that means is I want to get 22 oxygens from this other molecule. This molecule comes in pairs, so each molecule has 2 oxygens. So what I need 11 O2s in order to give me 24 O's total. So this is kind of a tricky one. So over here on the left, let's make sure we're good. We've got 2 oxygens from this first compound, and I've got 22 from my O2, so I've got 24 oxygens now. So now everything is balanced. So that was kind of a tricky one. Let's try this one. These 3 are kind of harder ones. So N, H, and O, N, H, and O. Got 1 N, 3 H's, 2 O's, 1 N, 2 H's, and 3 O's. So what do we want to balance first? Let's save the oxygen for last because oxygen shows up in several places. So let's do the hydrogens next. So 3 and a 2, lowest common multiple is 6. So let's make this a 2. Now I've got 2 times 1, I've got 2 nitrogens. 2 times 3, 6 hydrogens. So I'm going to put a 3 over here. So now I've got 3 times 2, I've got 6 hydrogens. And now my oxygens, I have 2 from the NO2, and I've got 3 from the H2O. So that is 5. Well, I got to balance out my nitrogens. Okay, so let's put a 2 right here. So that gives me 2 nitrogens. But then, I have to recount my oxygens again. Now I've got 4 from the NO2 and 3 from the H2O. So that is 7. So everything is balanced except for oxygen. And I've got this molecule over here where I'd love to have 7 oxygen atoms coming from this molecule. The only way to get that to work mathematically is if this were a 3.5. So I have 3.5 O2s, that would give me 7 oxygen atoms. But you can't have half of a molecule, so here's where you use this trick that you go through and you multiply everything by 2. So you double everything. So instead of a 2, this becomes a 4. Instead of 3.5, this becomes a 7. This is getting kind of messy here. Instead of a 2, this becomes a 4, and this becomes a 6. So my balance coefficients are 4, 7, 4, 6. So that's our last trick there. When you're stuck, try multiplying everything by 2. There's another problem down here that's going to have the same Same trick here. So let's try one more. It's another combustion. So with combustions, remember CHO, do the C's first, then the H's, then the O's. And then it's with these combustion reactions that it often becomes helpful to try doubling everything. So when in doubt, try doubling. You can always go back and undo it if you need to. Alright, so I've got my initial count here. So I'm going to balance the carbons first. So I'm going to put a 4 here, 4 carbons. Then I balance my hydrogens. So I'm going to put a 5 here. That gives me 5 times 2, 10 hydrogens. And now I'm going to stop and count my oxygens. So 4 times 2, there are 8 from the CO2, and then 5 from the water. So I've got 13 oxygens. So, life would be great if I could just make this number a 6.5, because 6.5 times 2 is 13, then I would be all balanced. I can't have half of a molecule, though, so I'm going to have to go through and double everything. So 1 becomes a 2, 6.5 becomes 13, 4 becomes 8, and 5 becomes 10. So again, our ratios here are 2, 13, 8, 10 is what we're looking at there. Let's look at one more where you are given a word equation and you have to translate it into symbols. So we've got sodium metal. Sodium is not part of Hofbrinkel, so it's just Na. Water, H2O, produces sodium hydroxide. So you want to know that sodium is a +1 ion, hydroxide is a -1 ion. So do a little crisscross, and then we decide, we don't even need any subscripts here. So it's just going to be NaOH. And hydrogen gas is H2. So you want to go through and you want to count your sodiums, your hydrogens, and your oxygens. So I've got 1 sodium on each side. I got 2 hydrogens over here, 3 hydrogens over here, 1 oxygen, 1 oxygen. So let's try balancing this. Let's try balancing our O's here. So did I count let's look at our H's. So what if we add a 2 over here? That'll give me 2 sodiums, and then 2 oxygens, and then 2 plus 2, I've got 4 hydrogens. And then over here, if I put a 2, that'll give me 4 hydrogens, and then 2 oxygens. So yay, my hydrogens and oxygens are balanced. And then I need my sodium to be balanced, so let's do this right here. So there's an example of writing a balanced chemical equation from words. All right, thank you.